Hey everyone, welcome. So today, we're not just going to talk about AI. We're actually going to look inside it. We're going to treat it less like some, abstract cloud of intelligence and more like a machine with blueprints that we can actually read and understand. So let's pop the hood and see what's going on under there.
Okay, so the first thing we're going to do is pull back the curtain a little bit. Because behind all the hype, all the sci-fi stuff you hear about, the engine that's really driving this whole revolution, well, it isn't magic. Not at all. It's something way more concrete.
So let's just start with the big one, right? The question that's probably on your mind. When you're interacting with an AI, are you talking to a thinking, conscious being? Is it a digital brain that works just like ours? I mean, it can definitely feel that way sometimes, can't it?
Well, the answer is a pretty simple and definitive no. What you're actually seeing is the result of a massive, incredibly complex, and really elegantly layered math equation. It's just pure calculation. It's not consciousness.
Okay, so to really get a grip on this, let's try a simple metaphor. I want you to forget the idea of a brain for a minute. Instead, picture something a lot more mechanical. Think of a giant plumbing system, but for information.
Now, the proper technical term for this whole structure is a neural network. And yeah, as you can see, the whole idea is inspired by the actual neural networks in our brains. But to really understand how it works, we're going to stick with our plumbing metaphor. It's just so much easier to visualize. So yeah, for the rest of our time here, just keep this one image in your head. A gigantic, sprawling system of pipes. A plumbing system that's designed to handle data instead of water.
All right, so every single one of these plumbing systems has three main parts. First up, you've got the input layer. Think of this as the big funnel where the water, our information, gets poured into the system. From there, it flows into the middle section, which we call the hidden layers. Now this is the real maze of pipes where all the heavy lifting happens. And finally, all that information arrives at the output layer. These are the faucets at the very end that give you the final answer.
But wait, how does the system actually control where all this information goes? I mean, it's not just sloshing around in there randomly, right? No, it's an incredibly controlled process. And here's why. At every single junction in this huge network of pipes, there's a valve. A little digital valve that can be opened or closed or kind of set somewhere in the middle. And that is what precisely controls the flow of all that data. Okay, pay attention here, because this is where we translate the confusing tech jargon into our simple plumbing metaphor. When you hear an AI expert talk about a weight, all they mean is how tight a specific valve is, how much water it's letting through. And when they say bias, just think of it as a preference. The valve is kind of preset to make it a little easier for the flow to go one way versus another. It gives the path a little nudge. That's all it is, weights and biases. And that, right there, brings us to what it actually means to train an AI. It's literally just the process of adjusting every single one of those valves, all the weights and biases, over and over and over again. We're talking millions, sometimes billions of times. The whole goal is to fine-tune the entire system so that when you pour a question in one end, the right answer flows out of the correct faucet at the other end. But of course, it doesn't get it right every time, especially not at the beginning. The system has to learn from its mistakes. Or, to stick with our metaphor, it has to learn from its leaks. So what happens when things go wrong? Let's say you ask it to identify a picture of a cat, but the information flows out of the faucet labeled dog. The system made a mistake. So how does it fix itself? This, right here, is probably the most clever part of the whole design. It uses a process called backpropagation. And honestly, it's pretty much exactly what it sounds like. The system literally works backward from the mistake to figure out what went wrong. So check this out. Here's how the system fixes one of its leaks, step by step. First, the wrong faucet turns on. You get the wrong answer. That mistake creates an error signal, which then gets sent backward through the pipes. Think of that signal like a detective, tracing the flow back to pinpoint exactly which valves were the biggest culprits. And then finally, this system makes a tiny adjustment to those specific valves. Now just imagine that process happening billions of times. That's learning. So when you zoom out from all these individual pipes and all these little valves, what you're left with is, well, it's something truly remarkable. You've got a functional brain built entirely out of code and math.
And, we should never forget where this idea came from. This entire architecture, this whole concept of interconnected nodes passing information around, it was directly inspired by the biological machine that's sitting inside our own skulls. It's basically our attempt to recreate the pattern of our own intelligence.
And just to give you a sense of the sheer scale we're talking about here, a model like GPT-3 has 175 billion adjustable parameters. In our plumbing metaphor, that is 175 billion individual valves that the system has to learn how to tune perfectly. The complexity it's just staggering to think about.
And maybe the most profound part of this whole story is where we are now. This system, this code that was inspired by our own biology, is now actually starting to outperform us, its own inspiration, in really specific, really complex tasks. It's kind of like the student is starting to surpass the master.
And all of this leaves us with one final, pretty fascinating question to think about. We've just seen what's possible with a giant system of pipes, but what happens when we build an ocean? What new kinds of intelligence might emerge when we get to that scale? Thanks so much for joining me on this little tour of AI's architecture.